Hello and welcome. In this video, we'll walk through a series of beginner-level DevOps Intern interview questions and answers. We've grouped these questions into categories so you can focus on one topic at a time. We'll cover everything from technical basics like Linux and networking to essential DevOps tools, think Git, Docker, Terraform, CI/CD fundamentals, cloud concepts, monitoring and QA, and even some soft skills and situational questions. Each question is followed by a clear, concise answer suitable for a beginner. By the end, you'll be better prepared to ace that DevOps intern interview. So let's dive in. Transition. Let's start with the fundamentals, some technical knowledge you should have as a DevOps beginner. In this segment, we'll cover foundational technical questions. As a DevOps intern, you're expected to have basic knowledge of Linux, simple scripting, and networking concepts. Let's tackle some common questions in this area. What is Linux? Answer: Linux is an open-source operating system based on Unix. It's widely used on servers and development machines because of its stability, security, and flexibility. In DevOps, knowing Linux is important since many servers and tools run on Linux, and it gives you the ability to script and automate tasks at the operating system level. Name some basic Linux commands and their purpose. Answer: there are several basic Linux commands that every beginner should know. For example, ls lists files in the current directory, cd changes the current directory, pwd prints the current working directory, and mkdir creates a new directory. These commands help you navigate and manage the file system directly from the terminal, which is a common task in a DevOps role. What is a shell script? And how is it useful? Well, a shell script is essentially a file containing a series of shell commands, which is like a small program designed to be run by the Unix or Linux shell. In simpler terms, it's a text file with a list of commands that automate tasks you would normally execute one by one in a terminal. Shell scripts are useful for automating repetitive tasks like setting up environments, deploying applications, or processing files. This not only saves time, but also reduces the chance of human error. What is SSH and why is it used? SSH, or Secure Shell, is a network protocol used to securely log in to remote systems and execute commands on them. It provides an encrypted connection between your machine, which is the client, and the remote server, ensuring that data like passwords or commands is protected from eavesdropping. What is an IP address? An IP address is a unique identifier for a device on a network, kind of like the device's home address on the internet. IP stands for Internet Protocol, and an IP address consists of a series of numbers and dots in the IPv4 format that identifies each computer or device on the internet or a local network. Knowing this is fundamental for networking, for instance, when you configure servers or set up containers, you'll deal with IP addresses to allow systems to communicate with each other. Great, you've covered the technical basics. Next, let's move on to some questions about DevOps tools, the bread and butter of a DevOps role. DevOps relies on various tools for version control, automation, and infrastructure management. In this section, we'll go through beginner questions on popular DevOps tools like Git and GitHub, Docker containers, configuration management with Ansible, and infrastructure as code with Terraform. What is Git and why is it important in DevOps? Git is a distributed version control system used to track changes in code over time. It allows multiple developers to work on the same codebase simultaneously without overriding each other's changes by keeping a history of every change. You can think of version control like Google Docs revision history, but for code. It lets you see, merge, and revert changes as needed. In DevOps, Git is crucial because it enables collaboration and continuous integration. All code, whether it's infrastructure code, application code, or configuration, can be version controlled and managed reliably. What are GitHub and GitLab, and how do they relate to Git? GitHub and GitLab are web-based platforms for hosting Git repositories and facilitating collaboration. Essentially, they provide a remote place to store your Git-tracked code and add extra features like issue tracking, pull or merge requests, and CI/CD integration. GitHub is a popular hosting service for Gitty repositories, offering version control and collaboration features over the web. GitLab offers similar functionalities and also includes a built-in CI/CD tool. Both platforms allow teams to work together on code from anywhere using Git as the underlying version control system. What is Docker? Well, Docker is an open platform for developing, shipping, and running applications using containers. A container is like a lightweight, portable environment that includes an application and all of its dependencies, so it can run reliably on any system. It's much like a shipping container, ensures goods are transported intact regardless of the ship or port. Docker makes it easy to package software into these containers. In DevOps, Docker is important because it allows consistent environments from development to production. It works on my machine issues are minimized when everyone runs the same containerized application. What is Ansible and what is it used for? Ansible is an open-source automation tool primarily used for configuration management, application deployment, and other IT orchestration tasks. In practice, you write simple YAML scripts called playbooks that describe the desired state of your systems. For example, which packages should be installed or which services should be running, and Ansible will execute those steps on your servers. It's agentless, meaning it connects over SSH and doesn't require special software on target machines. For a DevOps team, Ansible helps ensure that all servers are configured consistently and can be set up or updated with one command rather than manually configuring each server. What is Terraform and how does it fit into DevOps? Terraform is an open-source infrastructure as code IAC tool created by HashiCorp. It allows you to define cloud infrastructure resources like servers, databases, networks in human-readable configuration files. And then it provisions those resources for you. In other words, rather than clicking around a cloud provider's UI, you describe your infrastructure in code and Terraform will create and manage those resources. This approach brings the benefits of version control and automation to infrastructure management. In a DevOps context, Terraform is used to set up and tear down environments reliably and consistently, often as part of a CI/CD pipeline, ensuring that infrastructure changes are tracked just like application code. Now that we've discussed tools, let's talk about the CI/CD fundamentals, continuous integration and delivery deployment, and the tools that make automation possible. CI/CD stands for continuous integration and continuous delivery or deployment. This is at the heart of DevOps, enabling teams to integrate code and deliver software updates faster and more reliably. In this section, we'll cover what CI/CD means and some popular tools like Jenkins, GitHub Actions, and GitLab CI that facilitate these practices. What is CI/CD? CI/CD stands for Continuous Integration and Continuous Delivery or Deployment. Continuous integration is the practice of frequently merging code changes into a shared repository where automated builds and tests run to catch issues early. Continuous delivery and its more automated form, continuous deployment, focuses on automatically releasing those tested changes to environments. In summary, CI/CD is about streamlining and automating the software release process. Developers integrate code regularly, and those changes can be delivered to production quickly and safely through automation. This reduces manual errors and allows for rapid iterative development. What is Jenkins and what is it used for? Jenkins is an open-source automation server often used to set up CI/CD pipelines. It helps automate the parts of software development related to building, testing, and deploying code. In other words, Jenkins can pull your code from a repository, for example, on a Git commit, run build scripts or tests, and then deploy the application or deliver artifacts. It's highly extensible with plugins, which is why it's popular in many DevOps teams. For a beginner, you can think of Jenkins as the automation robot that handles repetitive tasks in the development lifecycle, ensuring each code change is integrated and delivered in a consistent way. What is GitHub Actions? Well, GitHub Actions is a CI/CD platform built right into GitHub. It allows you to automate your software workflows directly from your GitHub repository. With GitHub Actions, you define workflow files, typically YML files, that specify a series of steps like build, test, and deploy, which should run on certain events, for example, when code is pushed or a pull request is opened. For instance, you could have an action that automatically runs your test suite whenever someone pushes new code to the repository. It's a convenient way to implement CI/CD, especially if your code is already hosted on GitHub. What is GitLab CI and how is it used? GitLab CI/CD is an integrated continuous integration and delivery tool that comes built in with GitLab. It automates the build, test, and deployment of code changes whenever you push to your GitLab repository. In GitLab CI, you define a gitlab-c.yml file in your repo describing the pipeline of jobs, stages like build, test, and deploy. GitLab runners then execute those jobs on GitLab's infrastructure or your own runners. Essentially, GitLab CI provides similar capabilities to Jenkins or GitHub Actions, but within the GitLab ecosystem. It's the mechanism that checks your code and delivers your application continuously. What's the difference between continuous delivery and continuous deployment? The difference is in the level of automation to production. In continuous delivery, every change is automatically tested and prepared for a release to production. But the actual deployment to production is a manual step. The team decides when to push the button. In continuous deployment, every change that passes the automated tests is automatically deployed all the way to production, with no manual intervention. In short, continuous delivery ensures you could deploy anytime, as the build is always in a deployable state, whereas continuous deployment does deploy every change immediately. Both rely on a robust CI process. Continuous deployment is just a more automated extension where releases are truly continuous. Good work. Now let's switch gears to cloud and infrastructure, where you might be asked about cloud providers like AWS or Azure and infrastructure concepts like virtual machines and infrastructure as code. DevOps often involves working with cloud platforms and understanding infrastructure. Interviewers will likely check if you know the basics of cloud computing, popular cloud providers, and concepts like virtual machines and infrastructure as code. Let's go through some common questions in this domain. What is cloud computing? Answer: cloud computing refers to the on-demand delivery of IT resources and services, like servers, storage, databases, networking, and software, over the internet with pay-as-you-go pricing. Instead of owning and maintaining physical servers or data centers, companies can rent compute power or storage from cloud providers, such as AWS, Azure, or Google Cloud, and scale those resources up or down as needed. In simpler terms, the cloud is someone else's computers that you use via the internet. This is fundamental in DevOps because most modern infrastructures are in the cloud. Understanding the concept means you realize you can provision resources on demand and only pay for what you use. What is AWS? Answer: AWS, or Amazon Web Services, is a comprehensive cloud computing platform provided by Amazon. It offers a wide range of cloud services, including virtual servers known as EC2, storage solutions like S3, databases such as RDS, and many more, all on a pay-as-you-go model. AWS is one of the most popular cloud providers in the industry. For a DevOps role, you might not need to know every AWS service, but you should understand that AWS provides the infrastructure and tools to build and deploy applications in the cloud. For example, you might use AWS EC2 instances to host applications, or AWS S3 for storing build artifacts. What is Azure? Answer: Microsoft. Azure is a cloud computing platform and infrastructure created by Microsoft for building, deploying, and managing applications and services through Microsoft-managed data centers. Just like AWS, Azure provides services like virtual machines, storage databases, and more, but in Microsoft's ecosystem. Companies that are more aligned with Microsoft technologies often use Azure. As a beginner, understand that Azure is another major cloud provider similar to AWS in concept, and knowing the basics of Azure services can be a plus. For example, Azure Virtual Machines, Azure Blob Storage, and so on, which parallel AWS's offerings. What is a virtual machine, or VM? Answer: a virtual machine is an emulation of a computer system. Essentially, it's a computer inside a computer. A VM runs on a host machine but behaves like an independent computer with its own operating system and allocated resources like CPU, memory, and storage. For example, using a VM, you can run a Linux OS on a Windows machine or vice versa, as if it were a separate physical computer. In cloud platforms like AWS or Azure, when you provision a server, like an EC2 instance on AWS or an Azure VM, you are essentially creating a virtual machine. VMs are important in infrastructure because they allow better utilization of physical hardware and flexible isolation of different applications or environments. What is infrastructure as code, or IAC? Answer: infrastructure as code is the practice of managing and provisioning infrastructure like servers, networks, and databases using code and automation tools rather than by manual configuration. This means you define your infrastructure in configuration files or scripts. For instance, writing a file that says, create 2 servers, a load balancer, and a database. Tools like Terraform or CloudFormation will read this code and set up the specified resources for you. The benefits of IAC are huge. It ensures environments are consistent, so no more works on my machine problems. It's repeatable, meaning you can destroy and recreate environments reliably. And it's version controlled, so infrastructure changes can be reviewed and tracked just like application code. In a DevOps setting, IAC is fundamental for automation and scaling infrastructure efficiently. Next up, let's discuss monitoring and QA, how we keep an eye on systems and ensure software quality, including tools like Prometheus, Grafana, and Selenium. A big part of DevOps is not just deploying applications, but also monitoring them and ensuring quality through testing. In this section, we'll cover some basics of monitoring and why it's important, as well as QA, or quality assurance, and test automation tools like Selenium. What is monitoring and why is it important in DevOps? Monitoring in DevOps is the process of continuously collecting, aggregating, and analyzing data about your systems and applications to understand their performance and health. This typically involves tracking metrics like CPU usage, memory, request rates, and logs, and setting up alerts if something goes wrong. For example, if a server goes down or response times spike. Monitoring is crucial because it provides visibility. Without it, you wouldn't know if your new deployment caused a memory leak or if users are experiencing slow responses. In a DevOps culture of continuous improvement, monitoring feeds back information so teams can quickly detect issues, respond to incidents, and improve the system proactively. What is Prometheus? Prometheus is an open-source systems monitoring and alerting toolkit. In practical terms, Prometheus collects and stores metrics from different services, usually by pulling data or scraping from endpoints that expose those metrics. It stores these metrics as time series data, values tracked over time, and allows you to query them with a powerful language called PromQL to generate alerts or charts. Prometheus often works together with Grafana for visualization. For example, you could use Prometheus to track metrics like CPU load or web request duration for your application. And if certain thresholds are exceeded, say CPU greater than 90% for 5 minutes, Prometheus can trigger an alert to notify the team. What is Grafana? Grafana is an open-source data visualization and dashboard tool. It lets you take metrics and logs from various sources like Prometheus or CloudWatch and visualize them in the form of interactive graphs and dashboards. With Grafana, you can create a dashboard that, for instance, shows your application's key metrics like CPU, memory, and error rates in real time. This is extremely useful in DevOps. Instead of combing through raw data, you have a live dashboard to monitor system health at a glance. Grafana also supports setting up alerts like sending an email or Slack message if a metric goes out of range. In summary, Grafana helps convert all that monitoring data into insights by displaying it in an easy-to-understand way. What is QA, or quality assurance, in the context of software, and why is it important? Quality assurance in software is a systematic process to ensure the product meets the required quality standards and is free of critical bugs or defects. It encompasses practices like writing and executing tests such as unit tests, integration tests, and end-to-end tests, as well as code reviews and process checks to make sure the software behaves as expected. In a DevOps context, QA is often shifted left, meaning it's done early and continuously, for example, continuous testing in CI pipelines. The importance of QA is straightforward. It's much better to catch a bug in testing before it ever reaches a user or affects a production system. Good QA practices lead to more reliable releases, happier users, and less firefighting after deployment. What is Selenium and how is it used in testing? Selenium is a popular open-source framework for automating web browsers. It's commonly used for testing web applications by simulating user interactions in the browser, like clicking buttons, filling forms, and navigating to verify that everything works as intended. In other words, Selenium automates browsers. You can write scripts in languages like Python or Java that instruct the browser to perform actions and check the results. For a DevOps or QA beginner, this means instead of manually checking a web app after each deployment, you could have a Selenium test suite that automatically opens the app and runs through critical user flows, like logging in or adding an item to a cart to ensure nothing broke. Selenium is an important tool in the QA toolkit for achieving test automation and supporting continuous delivery with confidence. Finally, let's cover some soft skills and situational questions. DevOps is not only about tools and code. How you work in a team and handle situations is equally important. In this last section, we'll discuss a few common soft skill and scenario-based questions. Interviewers ask these to understand your motivations, how you handle learning and challenges, and how you operate in a team setting. There aren't right answers here like there are for technical questions, but it's important to answer thoughtfully and honestly, showing that you have a positive attitude and problem-solving mindset. Why are you interested in DevOps? Answer: I'm interested in DevOps because I enjoy both software development and system administration, and DevOps is the perfect blend of the two. I love the idea of automating processes and improving efficiency. For instance, the concept of continuous integration and deployment excites me. It's satisfying to see code go from development to production smoothly. Additionally, I appreciate the collaborative culture of DevOps, developers and operations working together rather than in silos. I find that I learn a lot by bridging these areas, and it ultimately delivers better software faster, which is very rewarding to me. If you were asked to learn a new tool or skill that you're unfamiliar with, how would you approach it? Answer: if I need to learn a new tool, I usually start by reading official documentation or a beginner's guide to get an overview. Then I learn best by doing. So I would try to set up a small project or sandbox environment to play with the tool hands-on. I'm not afraid to ask for help. I'd reach out to team members or online communities like forums or Stack Overflow if I get stuck on something specific. For instance, when I first encountered Docker, I followed a tutorial to build a simple container, and that practical experience helped a lot. Generally, I break the learning process into steps: research, experiment, and apply to a real problem. This way, I can quickly get up to speed on new technologies. How do you handle tight deadlines or pressure in a fast-paced environment? Answer: under pressure, I stay calm by getting organized. I break down the work into smaller tasks and prioritize what needs to be done first. Communication is also key. If a deadline is very tight, I'll make sure to update my team or supervisor on progress and any roadblocks. That way we can adjust scope or get help if needed rather than having a last-minute surprise. I actually find that a little pressure can be motivating as long as I have a clear plan. For example, during a university project rush, I created a quick checklist of remaining tasks and tackled them one by one, which kept me focused. Also, I ensure to take short breaks to stay fresh rather than burning out in one go. In a DevOps context, if there was a pressing issue, say a server outage, I would follow our runbooks and step-by-step procedures, which helps manage the stress because you have a predefined process to resolve the problem. What would you do if you made a mistake that caused a problem in production? Answer: if I realized I made a mistake that impacted production, my first step is to remain calm and take responsibility. I would immediately inform the team or my supervisor about what happened. Transparency is important, and hiding a problem can make it worse. Next, I would focus on a solution. For example, if I deployed a bad configuration, I might roll it back to the last known good state using version control or IAC scripts. I'd work with teammates if needed to fix the issue as quickly as possible. After resolving it, I would analyze what went wrong. Was it a lapse in a process? Was there a missing test that could have caught this, and learn from it? Everyone makes mistakes, especially when learning, but the key is to fix fast, communicate openly, and implement improvements so it doesn't happen again. Employers understand that interns are learning, and they appreciate honesty and a problem-solving attitude when mistakes happen. How would you handle a disagreement with a colleague about how to implement a DevOps process or solution? Answer: in case of a disagreement, I believe the best approach is open communication. I would first make sure I fully understand my colleague's perspective. I'd listen to why they prefer their approach. Then I'd explain my viewpoint and the reasoning behind it. Often we might both have valid points, so I'd look for a common ground or even a way to test out both ideas on a small scale to see which works better. It's important to keep the discussion objective and focused on the problem, not personal. If we still can't agree, I'd suggest bringing in a third opinion, like consulting our team lead or an experienced engineer to weigh in. For example, if I think we should use tool A for deployment and my colleague insists on tool B, we could list pros and cons or run a quick proof of concept for each. Ultimately, the goal is the success of the project, so I'm willing to compromise or follow the decision that the team aligns on. The key is maintaining respect and team spirit, even when we have different ideas. That wraps up our 30-minute DevOps intern interview Q&A guide. We've covered technical basics, essential tools, CI/CD concepts, cloud infrastructure, monitoring and QA, and some soft skills scenarios. Remember, as a beginner candidate, interviewers don't expect you to know everything. They're interested in your fundamental knowledge, your willingness to learn, and how you approach problems. Use these questions as a starting point to prepare your own answers and anecdotes. Thank you for watching, and good luck with your DevOps internship interview. If you found this helpful, feel free to review these sections again and keep practicing. With preparation and a positive attitude, you'll do great. Good luck out.